In the grand theater of history, some figures appear as if from another time, their minds tuned to a frequency that the rest of the world has yet to discover. They are the visionaries, the dreamers, the architects of the future. And among them, one name shines with a particular electric brilliance: Nikola Tesla. His is a story of a mind that saw the world not as it was, but as it could be. A story of lightning harnessed, of power sent wirelessly through the air, of a future so audacious that even today we are still catching up to his dreams. This is not just the biography of an inventor, it is an exploration of a consciousness that operated on a different plane, a journey into the heart of a man who gave the world the foundations of the modern age, yet died alone and in obscurity. To understand our world of instant communication, of global power grids, of the very technology that surrounds us, we must first understand the story of the man who dreamt it all into being long before it was ever thought possible. Our story begins not in a gleaming laboratory, but in a small village in the heart of the Austrian Empire, in what is now modern-day Croatia. It was here, in the village of 𝘕𝘪𝘬𝘰𝘭𝘢, on a dark and stormy night in July of 1856, that Nikola Tesla was born. Legend has it that the midwife, unnerved by the violent lightning storm, declared it a bad omen. She said the child would be a child of darkness. But his mother, 𝘮𝘰𝘭𝘥, a woman of remarkable intellect and intuition, is said to have replied, "No, he will be a child of light." It was a prophecy that would prove astonishingly accurate. From his earliest years, young Nikola was different. He was possessed of a photographic memory and an intense, almost supernatural ability to visualize complex machinery in his mind, to build, test, and refine his inventions without ever touching a physical object. He saw flashes of light, often accompanied by vivid images, a strange neurological condition that both tormented and inspired him. He was a voracious reader, devouring every book he could find in his father's extensive library, his mind a sponge for knowledge. His father, Milutin Tesla, a Serbian Orthodox priest, hoped his son would follow him into the clergy. But Nikola's destiny lay not in the spiritual realm of the church, but in the equally mysterious and powerful realm of electricity. The young Tesla's childhood was marked by both brilliance and tragedy. His older brother, Dane, was killed in a riding accident when Nikola was just 5 years old. The loss haunted him for the rest of his life, and some biographers suggest that his relentless drive to achieve was, in part, a way to honor the memory of his lost brother. His mother, 𝘮𝘰𝘭𝘥, was a significant influence on his life. Though she had no formal education, she was a woman of exceptional ingenuity, inventing household tools and devices to make her work easier. Tesla would later credit her with inspiring his own inventive spirit. She taught him to see problems not as obstacles, but as opportunities for creative solutions. This mindset would become the foundation of his approach to science and invention. His fascination with electricity began in earnest during his studies. He attended the Higher Real Gymnasium in Karlovac, where he was a brilliant student, completing the 4-year course in just 3 years. It was here that he first encountered a Graham dynamo, a machine that could be used as both a generator and a motor. He was captivated. The sight of this machine, with its spinning armature and crackling sparks, ignited something deep within him. It was a glimpse into a world of invisible forces, a world that he would spend the rest of his life trying to understand and master. But his path was not a straight one. After finishing his studies, he contracted cholera and was bedridden for 9 months, near death on several occasions. In a moment of desperation, his father promised that if he recovered, he would send him to the best engineering school in the world. Nikola did recover, and his father kept his promise. In 1875, Tesla enrolled at the Austrian Polytechnic in Graz, Austria. He was an exceptional student, never missing a lecture, earning the highest grades, and working from 3 in the morning until 11 at night. He was driven by a relentless curiosity, a burning desire to understand the fundamental principles of the universe. It was during his 2nd year at Graz that his destiny was sealed. He was in a lecture on direct current, or DC, electricity. The professor was demonstrating a Graham dynamo, which, like all DC machines of the time, used a commutator, a sparking, inefficient device that transferred electricity to the motor. Tesla, with his intuitive grasp of physics, saw that the commutator was a fundamental flaw. He suggested that it might be possible to create a motor that ran on alternating current, or AC, without the need for a commutator. His professor was dismissive, even scornful. He devoted an entire lecture to refuting Tesla's idea, declaring it impossible, a perpetual motion machine. The professor's words were harsh, but they had the opposite effect of what was intended. Rather than discouraging Tesla, they ignited a fire within him. The challenge had been issued, and for the next 6 years, the problem of the AC motor would consume him. It became an obsession, a puzzle that he could not let go. He would think about it constantly, turning it over in his mind, searching for the solution that eluded him. After leaving Graz, Tesla's life entered a period of drift and hardship. He moved to Maribor, where he worked as a draftsman for a pittance. He suffered a nervous breakdown. He was eventually persuaded to return to his family, but the dream of the AC motor never left him. He then moved to Prague to study at the university, but his time there was short-lived. His father died, and he was forced to leave his studies to support his family. He found work at a new telephone exchange in Budapest, and it was there, while walking through a city park with a friend, that the solution to the problem that had haunted him for years came to him in a flash of insight. As he recited a passage from Goethe's Faust, the vision appeared before his eyes, fully formed, a revelation. He saw a motor with a rotating magnetic field, a motor that would run on alternating current, a motor that would change the world. He drew the design in the sand with a stick, a simple diagram that held the key to a new era of electrical power. It was a moment of pure, unadulterated genius, a testament to the power of the human mind to see beyond the limitations of the present. The rotating magnetic field was the key. Instead of trying to force electricity to flow in one direction, as DC did, Tesla's system used the natural oscillation of alternating current to create a field that rotated, pulling the motor's rotor along with it. It was elegant, efficient, and revolutionary. In 1884, with a letter of recommendation from his former employer to Thomas Edison, Tesla arrived in New York City. The letter, as legend has it, simply read, "I know two great men, and you are one of them. The other is this young man." Edison, the established wizard of Menlo Park, was a man of practical, brute force invention. He was a master of direct current, or DC, a system that powered his incandescent light bulbs but was inefficient over long distances. Tesla, with his mind ablaze with visions of alternating current, or AC, was a different kind of genius. He was a visionary, a man who saw the universe as a symphony of frequencies and vibrations. The two men were destined to clash. Edison hired Tesla, and for a time, the young Serb worked diligently, improving Edison's DC dynamos. But their fundamental disagreement over the future of electricity was a chasm that could not be bridged. Edison was dismissive of AC, calling it impractical and dangerous. Tesla, on the other hand, knew that AC was the key to a new era of power, a way to transmit electricity over vast distances with minimal loss. The final break came over a dispute about a promised bonus. Edison had offered Tesla $50,000 to redesign his DC dynamos, a task Tesla completed with remarkable success. But when Tesla asked for the money, Edison laughed it off as a joke, a misunderstanding of American humor. For Tesla, it was a bitter lesson in the ways of the world, a world that often valued profit over genius. He left Edison's company, his pockets empty, but his mind still full of dreams. The period that followed was one of great hardship for Tesla. He was forced to take a job digging ditches to survive, his brilliant mind occupied with manual labor. It was a humiliating experience for a man of his intellect and education. He later described this period as one of the darkest of his life. But even in the trenches, his vision did not dim. He continued to refine his ideas for an AC system, a system of motors, generators, and transformers that would work in perfect harmony. His break came when he met Alfred S., Brown, a superintendent at Western Union, and Charles F. Peck, a New York attorney. These two men recognized the potential of his inventions. They formed the Tesla Electric Company, and for the first time, Tesla had a laboratory of his own, a place where he could bring his visions to life. In 1888, he was granted patents for his polyphase AC induction motor and related transformers, inventions that would revolutionize the generation and distribution of electricity. These patents caught the attention of George Westinghouse, an inventor and industrialist who was Edison's chief rival. Westinghouse understood the immense advantages of AC over DC. He saw that Tesla's system was the key to building a nationwide power grid, and he bought Tesla's patents, offering him a generous sum and a position as a consultant. The stage was set for one of the great technological battles of the industrial age, the War of the Currents. It was a war fought not on battlefields, but in newspapers, in public demonstrations, and in the boardrooms of corporate America. Edison, a master of public relations, launched a vicious campaign to discredit alternating current. He staged public electrocutions of animals, from dogs and cats to an elephant named Topsy, all to demonstrate the supposed dangers of AC. He lobbied state legislatures to adopt AC for the newly invented electric chair, forever associating it with death in the public mind. The tactics were ruthless, and they were designed to instill fear in the hearts of the public. Edison wanted people to believe that AC was a killer, a force too dangerous to be allowed into their homes. Tesla, for his part, was a showman in his own right. In a series of dazzling demonstrations, he would pass high-frequency AC currents through his own body, lighting up lamps in his hands, his body wreathed in a harmless corona of electric fire. He was proving that AC, when properly understood and controlled, was not the monster Edison made it out to be. He would stand before audiences, his body glowing with electricity, a living testament to the safety and power of his system. The demonstrations were not just scientific, they were theatrical, designed to capture the imagination of the public and to counter Edison's fear-mongering. The climax of the War of the Currents came at the 1893 World's Columbian Exposition in Chicago. It was a chance to showcase the power and beauty of alternating current on a grand scale. Westinghouse, with Tesla's system at its core, won the contract to illuminate the fair. The result was a spectacle of unprecedented brilliance. The White City, as it was called, was a dazzling display of electric light, a vision of a future powered by clean, efficient, and abundant energy. The fair was a triumph for Tesla and Westinghouse, a decisive victory in the War of the Currents. Millions of visitors walked through the illuminated grounds, marveling at the power of electricity. It was a turning point in public opinion, a moment when the world began to see the potential of AC. The final vindication came a few years later with the construction of the first hydroelectric power plant at Niagara Falls. The mighty falls, a source of wonder and awe for centuries, were now harnessed to generate electricity, and it was Tesla's AC system that made it possible. Power from Niagara was transmitted to the city of Buffalo, 20 miles away, a feat that would have been impossible with DC. The age of alternating current had begun. The dream that had haunted Tesla since his days in Graz was now a reality, powering cities and transforming the world. With the victory of alternating current secured, Tesla's mind soared to even greater heights. He established his own laboratory in New York City, a place of wonder and mystery where he conducted experiments that seemed to border on the magical. It was here that he invented the Tesla Coil, a device that could generate high voltage, low current, high frequency alternating current electricity. The Tesla Coil was a dramatic and visually stunning invention, producing spectacular displays of electrical arcs and bolts of man-made lightning. But for Tesla, it was more than just a toy. It was a tool for exploring the very nature of electricity and for realizing his most ambitious dream, the wireless transmission of energy. He envisioned a world where power could be broadcast through the air, just like radio waves, a world without wires, where energy would be free for all. He conducted experiments in which he lit up fluorescent lamps from a distance without any physical connection. He was on the verge of a technology that could have transformed the world in ways we can still only imagine. The Tesla Coil became a symbol of his genius, a device that captured the imagination of the public and demonstrated the seemingly limitless potential of electricity. His work on wireless communication also led him to the invention of radio. While Guglielmo Marconi is often credited with the invention of radio, it was Tesla who first developed and patented the basic principles of radio technology. He demonstrated a radio-controlled boat in 1898, a feat that was so far ahead of its time that many in the audience believed it was magic or telepathy. The boat, a small model, responded to commands sent wirelessly from a control box. It turned, it stopped, it reversed direction, all without any visible connection. It was a demonstration of remote control, a concept that would become fundamental to modern technology. But Tesla was not interested in the commercial applications of his inventions. He was a visionary, not a businessman. He was driven by a desire to understand the universe and to create technologies that would benefit all of humanity. This, perhaps, was his greatest strength and his greatest weakness. He was a man of immense intellect, but he was also a man of profound and often debilitating eccentricities. He was obsessed with the number 3 and would walk around a block 3 times before entering a building. He had a phobia of germs and a revulsion for human hair. He would not shake hands, and he would not touch anything that was not perfectly clean. He was a celibate, believing that his creative energies would be dissipated by romantic entanglements. He once said that he had never touched a woman and that he had no desire to do so. He was a solitary figure, a man who lived in the world of his own mind, a world of dazzling inventions and grand, utopian visions. He dined alone, always at the same table at the same restaurant, and he would calculate the cubic volume of every piece of food before eating it. These habits, which might seem bizarre or even pathological to us today, were simply part of who he was. They were the price he paid for his extraordinary mental gifts. His grandest and most audacious project was yet to come. With funding from the financier J.P. Morgan, Tesla began construction of a massive tower on Long Island, New York. Known as Wardenclyffe, it was to be the cornerstone of a global system of wireless communication and power transmission. The tower, a giant mushroom-like structure rising nearly 200 feet into the air, was a marvel of engineering. It was designed to tap into the electrical energy of the Earth itself, to create a resonant circuit that would allow for the transmission of information and power to any point on the globe. Tesla envisioned a world where ships at sea could navigate without compasses, where news could be instantly transmitted across oceans, where anyone, anywhere, could tap into a limitless supply of free energy. It was a vision of a connected world, a world of abundance and peace, powered by the benevolent forces of nature. He believed that the Earth itself was a conductor, and that by sending electrical pulses into the ground, he could create standing waves that would circle the globe. These waves could then be tapped into by receivers anywhere on the planet, providing both communication and power. But it was a vision that was too far ahead of its time. Morgan, a shrewd businessman, was interested in a return on his investment. When he realized that Tesla's system was designed to provide free energy, he pulled his funding. The tower, a monument to Tesla's magnificent dream, was never completed. It stood for years as a silent, skeletal reminder of what might have been, before being dismantled and sold for scrap to pay off Tesla's mounting debts. The failure of Wardenclyffe was a crushing blow to Tesla. It was not just the loss of a project, it was the death of a dream. He had poured his heart and soul into Wardenclyffe, and its failure marked the beginning of his decline. The failure of Wardenclyffe marked a turning point in Tesla's life. He was now in his late 40s, and the tide of fortune was beginning to turn against him. He continued to invent, to file patents, to dream of new technologies. He designed bladeless turbines, explored the principles of cryogenics, and even claimed to have developed a particle beam weapon, a death ray that he believed would make war impossible. He envisioned a weapon that could shoot a beam of concentrated particles with such force that it could destroy aircraft from hundreds of miles away. He offered his invention to various governments, but no one took him seriously. But he was increasingly isolated, his ideas dismissed as the ravings of a madman. He became a recluse, living in a series of New York hotels, his only companions the pigeons he would feed in Central Park. He would spend his days in his hotel room, his mind still teeming with ideas, but with no laboratory, no funding, and no one to listen. He had given the world the alternating current system that powered its cities, the induction motor that drove its industries, and the radio that connected its people. Yet, he died in poverty and obscurity in a hotel room in New York in January of 1943, at the age of 86. The man who had illuminated the world died alone, his life's work largely forgotten by the public. His funeral was attended by a small number of people, a quiet end for a man who had once been celebrated as a magician of the modern age. But a legacy like Tesla's, a light so brilliant, cannot be extinguished forever. For decades, his name languished in the footnotes of history, a curious eccentric overshadowed by the more commercially successful inventors of his time. But slowly, as the 20th century gave way to the 21st, the world began to rediscover the man who had invented the modern world. In 1943, just months after his death, the US Supreme Court overturned Marconi's fundamental radio patent, posthumously recognizing Tesla's pioneering work in the field. It was a quiet vindication, a legal footnote to a life of grand, unacknowledged achievements. But his true vindication is not found in court rulings. It is found in the world we inhabit today, a world that is, in so many ways, a manifestation of his visionary imagination. Every time you turn on a light, you are tapping into Tesla's system of alternating current. The vast, intricate power grids that span continents, the silent, efficient motors that run our homes and our industries, are all built upon the foundations he laid. The induction motor, his masterpiece of elegant simplicity, is the workhorse of the modern world, found in everything from household appliances to industrial machinery. The very car company that bears his name, a company that has revolutionized the automotive industry with its electric vehicles, is a tribute to the man who first dreamed of a world powered by clean, sustainable energy. His work on wireless communication, once dismissed as fantasy, is now the bedrock of our connected world. The principles he developed in his experiments with radio waves are the foundation for everything from our smartphones and our Wi-Fi networks to our satellite communication systems. His demonstration of a radio-controlled boat in 1898 was not just a novelty, it was the birth of robotics, the first glimmer of a future where machines could be controlled from a distance without wires. His dream of a global wireless system, a way to transmit information and energy to any point on the planet, was a stunningly accurate prediction of the world we live in today, a world connected by an invisible web of information. Tesla was more than just an inventor. He was a poet of the electrical age, a man who saw the universe as a symphony of frequencies and vibrations. He was a philosopher of technology who believed that science should be used not for profit or for war, but for the betterment of all humanity. He was a man of profound contradictions, a solitary recluse who dreamed of connecting the world, a brilliant showman who was a terrible businessman, a man who gave the world riches beyond measure, yet died with nothing. His life is a cautionary tale about the price of genius, about the struggle between vision and commerce, between the desire to create and the need to survive in a world that does not always recognize its greatest benefactors. He was a man out of time, a visitor from the future who lived among us for a brief, brilliant moment. So the next time you see the city lights blaze to life against the night sky, the next time you connect to a wireless network, the next time you marvel at the seamless power of modern technology, remember the man who made it all possible. Remember the child of light, born in a thunderstorm, who grew up to harness the lightning. Remember Nikola Tesla, the man who invented the 20th century and whose dreams are still shaping the 21st. His name may have been written out of the history books for a time, but his legacy is written in the very fabric of our world, in every electrical circuit, in every radio wave, in every spark of innovation that continues to push the boundaries of what is possible. The story of Nikola Tesla is not a tragedy. It is a testament to the enduring power of a single, brilliant mind to illuminate the world and to leave a legacy that will shine for generations to come. The light he ignited has never gone out. It is all around us, and it is still growing brighter every day. To truly understand the breadth of Tesla's genius, we must look beyond the alternating current system and explore the sheer diversity of his inventions and discoveries. His mind was a fountain of ideas, constantly bubbling with new concepts and innovations. He held nearly 300 patents across multiple countries, covering everything from electrical generation and transmission to mechanical engineering and even theoretical physics. Each invention was a testament to his unique ability to see connections that others missed, to envision solutions that seemed impossible, and to bring those visions into reality through sheer force of will and intellect. Consider the Tesla turbine, a bladeless turbine that used smooth discs instead of blades to harness the energy of fluids. Unlike conventional turbines, which rely on the impact of fluid on blades, the Tesla turbine uses the boundary layer effect and the adhesion of the fluid to the discs. It was an elegant design, simple in concept but revolutionary in execution. Tesla believed that his turbine could be more efficient than traditional designs, and he envisioned it being used for everything from power generation to propulsion. While it never achieved widespread commercial success during his lifetime, the principles behind the Tesla turbine continue to inspire engineers and inventors today. Modern researchers are revisiting his design, exploring its potential applications in renewable energy and microgeneration. Then there was his work on X-rays. In the 1890s, around the same time that Wilhelm Röntgen was conducting his famous experiments with cathode rays, Tesla was independently exploring similar phenomena. He produced X-ray images using his own equipment, and he made important observations about the nature of these mysterious rays. He even sent some of his X-ray photographs to Röntgen, who was impressed by the quality of the images. Tesla's work in this area was cut short by a laboratory fire in 1895, which destroyed much of his equipment and research. But his contributions to the early understanding of X-rays are undeniable, even if they have been largely overshadowed by Röntgen's more famous discoveries. Tesla also explored the concept of resonance with an intensity that bordered on obsession. He understood that every object has a natural frequency at which it vibrates, and that if you apply a force at that frequency, you can cause the object to vibrate with increasing amplitude. He demonstrated this principle with a small mechanical oscillator, a device that he claimed could, if attached to a building, cause it to shake itself apart. In one famous anecdote, he attached his oscillator to a steel beam in his laboratory, and within minutes, the entire building was shaking. He quickly smashed the device with a hammer to stop the vibrations, fearing that the building would collapse. While the story may be somewhat embellished, it illustrates Tesla's deep understanding of resonance and his willingness to push the boundaries of experimentation, even at great personal risk. His experiments with high-frequency currents led him to discover what are now known as Tesla waves, or longitudinal waves. He believed that these waves, which he claimed were different from the transverse electromagnetic waves described by James Clerk Maxwell, could be used to transmit energy and information more efficiently than conventional radio waves. While mainstream physics has not fully embraced Tesla's theories about longitudinal waves, some researchers continue to explore the possibility that he was onto something that conventional science has yet to fully understand. His work in this area remains controversial, but it is a testament to his willingness to challenge established scientific dogma and to explore uncharted territories. Tesla was also fascinated by the idea of harnessing the energy of the natural world. He proposed schemes to extract energy from the temperature difference between the ocean's surface and its depths, a concept that is now being explored in the field of ocean thermal energy conversion. He envisioned using the rotation of the Earth itself as a source of power. He believed that the planet was a giant dynamo, and that with the right technology, humanity could tap into this vast reservoir of energy. While many of his ideas in this area were speculative and ahead of the technology of his time, they demonstrate his holistic view of the universe and his belief that nature held the keys to unlimited, clean energy. His notebooks, filled with sketches, equations, and cryptic notes, reveal a mind that was constantly at work, exploring the fundamental laws of physics and pushing the boundaries of what was thought possible. He wrote about concepts that would not be fully understood or developed until decades after his death. He speculated about the nature of matter and energy, about the possibility of tapping into zero-point energy, and about the existence of other dimensions. Some of his ideas were dismissed as fantasy, but others have proven to be remarkably prescient. He was, in many ways, a man who was thinking in the 21st century while living in the 19th and 20th. His influence extends far beyond the specific inventions and patents that bear his name. He inspired generations of scientists, engineers, and inventors to think boldly, to challenge conventional wisdom, and to pursue their visions with passion and determination. He showed the world that one person, armed with nothing but intellect and imagination, could change the course of history. He demonstrated that the pursuit of knowledge and the creation of new technologies were not just practical endeavors, but also acts of profound creativity and even spiritual significance. He saw himself not just as an inventor, but as a servant of humanity, using his gifts to create a better world for all. In the decades since his death, Tesla has become a cultural icon, a symbol of the misunderstood genius, the visionary who was ahead of his time. He has been the subject of countless books, films, and documentaries. His image adorns t-shirts and posters. His name is invoked by those who champion alternative energy, free energy, and technologies that challenge the status quo. He has become a hero to those who believe that the world is on the cusp of a new technological revolution, a revolution that will finally realize the dreams that Tesla himself articulated over a century ago. Whether or not all of his ideas were practical or scientifically sound is almost beside the point. What matters is that he dared to dream, and that his dreams have inspired countless others to do the same. The Tesla Museum in Belgrade, Serbia, houses many of his personal belongings, his notebooks, and his inventions. It is a place of pilgrimage for those who admire his work and his vision. Visitors can see the Tesla Coil in action, marvel at his intricate designs, and gain a deeper appreciation for the scope of his genius. The museum is a testament to the enduring fascination with Tesla and his legacy. It is a reminder that even though he died in obscurity, his contributions to the world have not been forgotten. Today, as we stand on the threshold of a new era of technological innovation, Tesla's vision seems more relevant than ever. We are witnessing a global shift towards renewable energy, towards electric vehicles, towards wireless communication technologies that are transforming the way we live and work. We are exploring the possibilities of artificial intelligence, of quantum computing, of technologies that would have seemed like science fiction just a few decades ago. And in all of this, we can see the echoes of Tesla's dreams. We can see the fulfillment of his vision of a world powered by clean, abundant energy, a world connected by invisible waves, a world where technology serves humanity rather than enslaving it. The story of Nikola Tesla is a reminder that the path of innovation is not always smooth, that genius is not always rewarded, and that the greatest visionaries are often those who are willing to stand alone, to challenge the established order, and to pursue their dreams even in the face of overwhelming obstacles. It is a story that should inspire us all to think bigger, to dream bolder, and to never give up on our own visions of a better future. Tesla's life teaches us that the true measure of success is not wealth or fame, but the impact we have on the world, the legacy we leave behind, and the inspiration we provide to future generations.